Okay, so in this video, I'm going to be talking about question 3 of Networks and Decision Mathematics from 2018 NHT Further Maths Exam 2. So in this question, all areas of the property require a constant supply of water. The following directed graph represents the capacity in litres per minute of a series of water pipes on the property connecting the source to the sink. So the source has been here and the sink is there. Okay, so when considering the possible flow through this network, different cuts can be made. Cut 1 is labelled on the graph above. Okay, and they're all going with the flow, these cuts here. So that means I've got 15, 20 and 25. So I'm going to go 15 plus 20 plus 25, and that's going to equal 16 litres per, oops, I don't have to put, I should actually just write it as litres per minute. Now, second question, on the graph above, draw a cut that has a capacity of 70 litres per minute. Label your answer clearly as cut 2. So let's do a couple cuts just so you can see what we're looking at. We potentially have a cut there, and let's get rid of some of this, and a cut there. All right, so if I go through this first one, I've highlighted, this would be 25, so 20 and 25. The next one, I've got 10 going with the flow, going against the flow, so I don't count it. And the reason it's going against the flow is because I've already cut it and it's not going to get anything there. And I've got this one here as well. So that means I've got 10, 10, 10, so 20 plus 40 would be 60. We know that's not the answer. We want 70. This one would be 10, 20, so 30 now. Not going to include this one because it's getting against the flow, but we're going to include this one here. So that's 40. So 30 plus 40 would give you 70. So just to make it a bit cleaner on here, the cut we'd put in is we'd go that, and we'd go cut 2, because that's what they want you to do. They want you to write it, draw it, and write it. C is determine a maximum flow of water in litres per minute from the source to the sink. Now, in this particular question, you can do it by the maximum flow, minimum cut approach, where it's a bit more trial and error. Or there's another method you can use, which you may or may not have seen. I've tended to call it the alternative method. Not necessarily an alternative one, but it's just different to what that standard maximum flow minimum cut is. So let's have a look. So what you're going to do is you're going to find some directions it's gone. So that's one of them. And I'll highlight why I'm doing that in a moment. So I'm going to go here. And let's leave it for the moment. I'm going to leave it as is. So what you do is you find the smallest number along there, and that happens to be 10, and you put a 0 next to it. Then you take 10 off everything there. So that becomes 5. That becomes 15. Then I put a 10 here because I'm going to add those up in a moment. Then I go 25, 40, and 20. So 20 is my smallest number on that path. So that becomes 20, and that becomes 5. So the idea is I can't, any place I've got a 0, oops, I should have put a 0 there. Any place I've got a 0, I can't actually go up that particular part of the path, okay? Because think of it's been blocked, okay? So that means I can't come anywhere along there because that's going to lead up to there, okay? I can't go along here at all because I'm blocked by this part here. So what I've got left is, let me go like 10, 20, 10, but I'm not blocked along it, so I can still continue along that spot there. All right, so that means I've got, what's my smallest number here is 10. So it becomes 0, it becomes 10, and that becomes 5. And now I can't actually go anywhere else because once I get to here, I'm pretty much blocked. And I'm blocked already there. So I put a 10, so that would be, so when we come to determine the maximum flow, it's going to be 10 plus 20 plus 10 would equal 40 litres per minute for that, the answer to that question. Okay, so that's how you would actually do. You can do it like that. Now, let's just as a final thing, just to quickly show you the reason that becomes a bit harder when you're trying to find that is your cut would actually be this, because you'd be 10. It's against the flow there. At this point, this is against the flow because you've already cut it, or it's not accessible, and you're left with that 20, and that's how you do it now. So in if you're doing the maximum flow, minimum cut approach, you're going to have to work that one out. If you miss it, you've got the answer wrong. Okay, so that finishes question 3.